everyone, welcome back to another fun video on my fun zone. Today we're going to be talking about a very interesting topic. This topic is rather simple to understand, but it's very interesting if you go really into detail. It's called arithmetic sequences. Well, it might sound familiar to you, but if it doesn't, don't worry. I'll share with you what it is in just a bit. But before that, why should I even care about arithmetic sequences? Why am I even sharing this with you today? I mean, after all, if you know what an arithmetic sequence is, you'd just be wondering, what's the point of knowing how the sequence 2, 4, 6, 8, 10, 12, 14, 16, well, what's the point of knowing how it works? Well, it's not exactly that, but let me show you. Look at this picture. This is a relatively complicated picture of simple interest. And simple interest is solely based on arithmetic sequences. Arithmetic sequences are the most common thing seen in the financial department, and geometric sequences, of course, but in simple interest, it's arithmetic sequences. Most money problems and all that, they're so often related to arithmetic sequences, you wouldn't even realize you're actually solving it using one. Oh, and here, look at these birthday balloons. Birthday balloons? Why did I put a picture of birthday balloons here? Oh, well, maybe because your birthday repeats once in a year, and that's what makes it special. And there you go, that's another example of an arithmetic sequence. See? It can be as simple as having your birthday just once in a year, because the common difference between each birthday is 1 year, and that is an example of how it appears in an arithmetic sequence. And ta-da! One of my favorite things, look at the rocket. So a rocket slowly gains altitude. So let's say after 1 second, it's gained 100 feet of altitude, and after 2 seconds, it's gained 200 feet. It means every second is gaining 100 feet of altitude. And just that simple is an arithmetic sequence. You can see this even when a plane is lifting off into the air, or for example, whenever a car is going into the road, like a car starts off at speed 0 miles per hour, and every second it increases by 10. So after 1 second, it'll be 10 miles per hour. After 2 seconds, it'll be 20 miles per hour. It's like that. All arithmetic sequences, right? Yeah, it's that simple. Okay, so let's get right to it. Now, I'm sure you've all seen this counting numbers 1, 2, 3, 4, 5, 6, 7, on and on. Yeah, but it's very boring to count these numbers. At least I don't like it. But just counting the numbers from 1 on to whatever you want, up to infinity, that itself is an infinite arithmetic sequence. Because the difference between each term is 1 each time. It's 1, 1, 1, 1. You're adding 1 from a term to get to the next term. Now here's another example that I'm sure we'd all know. 5, 10, 15, 20, and yeah. Here in this case, it's a common difference of 5, which means you take any term. If you add 5, you get the next term of that sequence. And let's say 1, 3, 5, 7, 9, 11. You could go. Here it starts off at 1 and the difference is 2. Now, I'm going to point out an important thing here. Just if someone tells you that I have two sequences, but both have a difference of 3 between each term, it's a common difference of 3, does it mean it's the same sequence? Think about that for a second. Now, if you have a common difference of 3, let me show you this. Your sequence could be 3, 6, 9, 12, 15, because it's 3 between each term. Or it could be 4, 7, 10, 13, 16, and you could keep going. But the numbers in each sequence are completely different. Like they're no same numbers. So just because it's the same common difference, it doesn't mean it's the same sequence. However, if it's the same starting value and the same common difference, then it is the same sequence. In this case, 3 and 4 are the starting values and they're not the same. So it's not the same sequence. So those are the two factors that define a sequence. the starting value and the common difference. Now, let's take a look at a general sequence. It'll be A1, A2, A3, A4. So, and let's let this keep going on further. Now, let's say that the common difference between any two terms of this sequence is D. So you add D each time to get to the next term. Now, D could be positive or negative, doesn't matter, but you're adding that. Okay, so if the difference between any two terms is D, then isn't it true that I can take A3 minus A2 and I'll get D? I can take A4 minus A3 and I'll get D. I can take A2 minus A1 and I'll get D. So for any term in the sequence, if you do an minus 1, you get D, which is the common difference of that sequence. Now, if the an minus 1 notation is confusing, an is just some arbitrary term in the sequence. Let's say the sequence comes on here, and then you have an minus 2, an minus 1, an plus 1, and it'll still keep going. So the an and an minus 1 are just arbitrary terms, but the point is, if you take any two consecutive terms and you take if you take a term and you subtract the preceding term from it, you will always get the common difference. This is true for any arithmetic sequence. So that's our first point. Now, this is an important fact to remember whenever you're given an arithmetic sequence. It can actually help you more than you think in a problem. Second, if we were to write all these terms in terms of just A1, how can we do that? Well, I did mention that the common difference was D, right? And I also did mention to get from term number 1 to term number 2, you have to add D, which means if the first term is A1, then the second term can be written as A1 plus D, correct? And the third term can be written as A1 plus D plus D. And this pattern keeps going, which means if you take any arbitrary term in the sequence an, it can be written as the previous term, which is an minus 1 plus D. And this is the recursive definition for any sequence. So let's say we were to take the sequence as simple as 2, 4, 6, 8, 10, 12. If we were to recursively define the sequence, now recursive definition of sequence means it relies on the previous values of the sequence. So if you wanted to find the 10th value, you'd need to know the 9th value. If you wanted to find the 9th value, you'd need to know the 8th value, and so on. It's like that. So the way you define this is you say term number 1, or generally we let the sequence t of n equal the sequence, and then we say t of 1, or term number 1 is equal to 2, as in this case. And then we say t of n is equal to t of n minus 1 plus 2. Now, where did I get this 2 from? Is because the common difference is 2. And this 2 here is the starting value. Now, this notation means exactly the same thing as an and an minus 1. In fact, we could have defined the exact same thing as like this. Actually, I'll use a different example this time. 1, 3, 5, 7, 9. Yeah, we could have done this, and what it would have turned out to be is we say a1, which is the first term, is equal to 1, and an is equal to an minus 1 plus 2. This 1 here is the starting term. This 2 here is the common difference between each term. Okay, so now it's clear how to define a sequence recursively. But a sequence doesn't have to be increasing, meaning it doesn't have to go 1, 3, 5, 7, 9. It can even go 9, 5, 9, 7, 5, 3, 1, right? It's an arithmetic progression is what an arithmetic sequence is. And the progression can either be negative or positive, so it doesn't really matter. Now we could have the sequence 10, 8, 6, 4, 2, 0, -2, -4, and it keep going. This is also an arithmetic sequence, just a negative arithmetic progression. In this case, the difference is -2. The common difference, you're adding -2 each time, or subtracting 2. So if we were to recursively define the sequence, if this sequence was equal to t of n, like that, then we'd say t of n is equal to t, which shows the first term, and t of n is equal to t of n minus 1. Now, t of n is a random term. T of n minus 1 is a term behind that random term. So the previous term, plus 2, or not plus 2, minus 2 in this case. So this, my -2 here, is the common difference. This is how you would recursively define a sequence. Now, let's look at non-recursive definitions, which means you don't need to know the value of any term previously to figure out the term, to figure out any other term in the sequence. So, all you need to do for given a recursive equation is you need to plug in the term number and you'll get the value of that term. So, I'm going to take an example here. It's going to be 3, 7, 11, let's see, 15, 19, and it could go on forever, right? Okay, what is the common difference between in this sequence? How can we find that? Well, remember what we said, we can just take a term and subtract the preceding term from it to get the common difference. So let's take these two terms. The common difference d is equal to 11 minus 7, which is equal to 4. And there you go. That right there is just the common difference. Alternatively, we could have taken any other two, but any two consecutive ones, so 15 and 9, 11 and 5, 3, 7, yeah, it doesn't really matter, any two consecutive ones. Now, the starting term is denoted by a, and the starting term here is 3, so we have a equals 3. Now, let's see some interesting pattern here. To get from 3 to the second term, you have to take one step. To get from 3 to the third term, you have to take 2 steps. To get from 3 to the fourth term, right here, you have to take 3 steps. To get from 3 to the fifth term, you have to take 4 steps. So you can assume this, and if you were to have the nth term of the sequence here, so let's have some term, this is the nth term of the sequence here. To get to the nth term of the sequence, you need to take n minus 1 steps from 3, right? It's just like when you have your fingers. To get from your thumb to your pinky, you need to take 1, 2, 3, 4 jumps in between, right? It's just like that, simple logic. So if I were to get to, if I wanted to find, let's say, the 15th term of the sequence, how would I do that? Well, you start with the starting value, so 3. Let me write the 15th term is equal to 3. You start with 3, the starting value. Then since it's a 15th term, you have to take 14 steps from 3. And each of those 14 steps, you increment by 4, which is the common difference, right? So in each of the 14 steps, you're going up by a value of 4. Excuse me. So when you do this, you get 3 plus 14 into 4, which is 56, which is 59. And there you go. Now, if you were thinking of writing down all from the terms from 1 to 15, then you could do that. But what if I asked you to find the 2056 term? What would you do? Write down 2056 terms? No, I don't think so. You'd have to use a better method. So if you're going to get to the 15th term, you'd have to take 14 steps from 3, and each of those steps has a value of 4, which means you're going up 4 in each step. And that's how we get 3 plus 14 times 4, which is 59. Now, let's say you had to get to the 100th term of the sequence. Now, you definitely don't want to go listing 100 terms, right? It's a waste of time. Again, you start off at 3, then you move 99 steps. You move 99 steps, and each of those 99 steps has an increment of 4. And this is just equal to 3 plus 99 times 4. Let's see, that's 396. And that's equal to 399. And there you go. In less than a minute, we found the 100th term of an arithmetic sequence. Isn't that cool? Like, wow. At least that amazes me. Now, let's not find specific term numbers. Let's say we were trying to find the nth term. Now, the nth term is obviously equal to, let's see, let's give the sequence a name, S of n, right? So nth term is S of n, which is, you start off at 3, and then this time it's not actually a number, it's n, it's a variable. So we use the same logic as before. To get to the nth term from the first term, you have to take n minus 1 steps, each of value 4. Again, 4 here is the common difference, and 3 is the starting term. And this will give you 3 plus 4n minus 4, which simplifies to 4n. 3 minus 4 is negative 1, so 4n minus 1. Now, all I did in this step here is I used the distributive property and multiplied out, just like basic arithmetic. So, look at that. Now, finding the nth term, we've just found a formula for finding the nth term, 4n minus 1, where n is the term number. So let's say we were to find the term number 250, the 250th term. All we do is plug it into this, and we get 4 into 250 minus 1, which is equal to 1,000 minus 1, which is 999. Simple formula, right? Now, these formulas are extremely useful for finding the nth term of any sequence. Excuse me again. Now, of course, 4n minus 1 is not the formula for all sequences, but you get the idea. So now, actually, this formula is actually a simplified formula right here, but the actual way to write the formula would, starting with the first term, would be 3 plus 4 into n minus 1. It would still give you the same answer. How do we get this though? The 3 here is the starting term, and the 4, well, what do you think that is? That's right, it's the common difference. So now what we're going to do is generalize this for all sequences. Let's say we had the sequence AN, which had S1. Yeah, let's not do that. Let's just say it's A1, A2, A3, A4, A5, and so on forever. Now, let's say the common difference in this sequence was D. So it means any two terms, so A3 minus A2 equals D, because we said the common difference here is D. Okay, so A3 minus A2 is D, and we're going to try the same thing to find the nth term in this sequence. It's not a magic trick that's going to happen. It's illusions. It's all just the same logic as we used before, but generalizing it. We start off at the first term, a1. What we're going to do from here, we need to get to the nth term. Like before, we have to take n minus 1 steps. And each of those steps has value d, right? D here, then d here, d. See? So it's n minus 1d. And there, I'm just going to switch those last two around, and you get a plus d into n minus 1 as the formula for an arithmetic sequence, the nth term of an arithmetic sequence. And this is the conclusion I wanted to show you today, the way you find the formula for an arithmetic sequence. Now remember here in this case, a1 here is the starting term, starting term, and d is the common difference between two terms, and n is the term number. All right, so that's about it for this video. I hope you enjoyed it. I can tell you that arithmetic sequences are so interesting to learn about. You can't stop learning about it. And watch out for my next video, which is going to be about arithmetic series. And an arithmetic series is nothing but the sum of all the terms in an arithmetic sequence. I'll talk more about that in the next video. Thank you so much for listening to this video, and please subscribe to my channel and give this video a huge thumbs up. See you in the next video.